Bismillah. Folks, welcome back to another one of the videos on transformation of functions. Click 167A star MathWatch CD. Okay, Mr. Zishan, we've put the number 2 in different places of arbitrary, yeah? We put 2 at the front, we put 2 outside, we put minuses outside in the previous videos, yeah? Now, where's 2 now? 2 is now not outside, it's now inside the function. So, when you put a number 2 inside the function, we need to know what does that 2 in that position do to the function. What it does, it compresses the function, it squeezes the function. So now here, for example, the sine function is change from 0 to 360, is that right? So when I put a 2 in there, it will now be the same cycle, it won't be over 360, but it will be over now 180. So we'll get the same amount of curve in there, but we'll squeeze it down. So let's put a little dotted line here. Okay, so the point that was originally at 90 will now be in half of the place, which will be the 45 point. Okay. Now, that point which is 180, what's half of 180?
90.
So that point will move down to here. Okay, if you half a 0, you still get 0. We're squeezing the graph down this way, squeezing down. So that point that's 180, that point there moves to here. That point that was there moves to half the space. It was 90, half 90 is 45. Okay, now this one's 270. Okay, so that one's going to move down to 135, which is going to be here. Okay, so what's half of 360? 180. So that point there moves all the way down to here. So what was now nice and big has been squeezed down in half the space. That's the effect of putting a 2 in there. You squash the graph along the x-axis. So let's now redraw that and see, do we get the original function? Okay, now, Umar, at the back, can you see the blue curve is that big, yeah? And what we've done for the blue, we've got that point there, we squeezed it down, and everything's been squeezed in appropriate portion here, Now, if you're going to do that function, we don't actually finish there, we have to draw another one in the same space. Okay, so let's repeat that again. So normally in the space of one cycle, we're now going to get how many cycles? 2 complete cycles in the same space. So let's draw another one. So, if we look at the symmetry of the shape, it's going to go from here to there, to here, 1, 2, and the symmetry of the shape is going to go up from here, to there, to here, and then 1, 2, then bottom. Done. So, I'll put a 2 inside the function. Saf, have you copied the red curve down on yours? Come on.
Yeah.
You have? That's good. You've done all this? I'll just finish myself now. Mr. Sas already done it before me. Good boy. So the sine function which is in blue has been squashed along which axis? Along the x-axis has been squashed in to give us the red curve. So the red curve is what? Y is equal to sin of 2x. Okay, are we happy with that? Okay, now what would happen if I put, rather than put a 2, I put a half in there? What happened? Rather than us squeezing the graph in, we would stretch it out. Stretch the graph out. So rather than, if I put a half in here now, rather than getting 2 complete cycles, you would get how many cycles now? Half a cycle. Half a cycle. So what would happen, you would, from here to there, you just get basically just the top loop there. Just that half will be stretched out. So now you're pulling it out. Okay, so that's how we get a half in there. Now, I want to quickly look at this next. This is an examination question, by the way. You'll find out on one of your papers that we'll be doing in a bit. What they've done here in the next question here, they've combined 2 transformations together. So the first one is the same as the one we just done. And the next one we've got a number outside. So we've got a number inside and outside. What is the inside function? What the inside one do? What does it do? squeeze it. What's the one outside do? Stretch it. So we do first, we squeeze it and then we stretch it. Have you already squeezed it? So our red one is our squeeze. Now what we're going to do, so this part here has already been done. This part here has already been done in red. And now we've got an additional 2 outside. So we're going to get the red one and now we're going to stretch that by a factor of 2. So let's do that in black. So 0 times by 2 is still 0. 0 times by 2 is still 0. All the 0 points stay exactly where they are. They don't move. Okay, Mr. Zishan. That was my new value there. That's 1. If I double the 1, what do I get?
2.
Okay, if I double the minus 1, what do I get? Double the minus 1 is? Minus 2. If I double the 1 here, what do I get?
2.
If I double the minus 1 here, what do I get? So now, let's try this one then. So the black graph is y is equal to 2 sine 2x. We have to do the inside one first and then the outside one, in that order. Okay, let's quickly recap that, Mr. Zishan. The blue function was the original sine function. Then we put a 2 inside the function and that squeezed it into the red graph, yes? The red graph is sine 2x. And then we said, well, we're going to do the same one and we're going to add another transformation to it, Ifra. Put a 2 outside as well. So that 2 outside is identical to the same one, but then we have to stretch it. So the blue graph became the red graph. The red graph got then stretched along the y-axis and became the black graph. Okay, and we're done. So sine 2x is the red one, 2 sine 2x is the black one, and we won't finish that one. Okay, now what I would like you to do, because since we've done it on this one here, I want you to do the same thing for the cos graph. So find a cos template on your homework diaries there and do exactly the same. Do cos of 2x for yours. I'll write it for you. You do now cos of 2x and cos of 2x and 2 in the front of it. Change your color. 2, 2, 2. You do that on the next template, please. Have a go at those, please.